In class, you've been talking about solving equations using logs or equations that have logs in them. So we're going to solve 4 problems. Our first example is solve log base 3 of x plus log base 3 of 4 equals 2. So the first thing I want to do is I want to rewrite my left-hand side here as 1 log. And so I'm going to use my product rule, which says that log base 3 of x plus log base 3 of 4 is log base 3 of 4x equals 2. I then need to apply the fact that logs and exponents are inverses of each other. And so I know that what this is telling me is that 3 to the second power equals 4x. So I have 9 equals 4x, which means I have x equals 9/4. Second example, solve log base 8 x squared minus log base 8 of 4x plus 1 equals 1. Again, I'm going to want to rewrite this so that everything is written as 1 log. So I have log base 8 of x squared over 4x plus 1 equals 1. I now need to rewrite this as an exponent. So I have 8 to the first power equals x squared over 4x plus 1. I am going to multiply both sides by 4x plus 1. So I get 32x plus 8 equals x squared. I need my equation to equal 0 because it's a quadratic equation. So I have x squared minus 32x minus 8 equals 0. Lots of different methods for solving this. You could use quadratic formula. You could use completing the square. I generally like completing the square best. So I'm going to have x squared minus 32x. I'm going to take my negative 32 divided by 2 and square it. So that's going to be 16 squared. So I'm going to have plus 256. And of course, I have to have my equation not change. So I have subtract 256 also. I rewrite my perfect square trinomial as a perfect square binomial. I simplify my minus 256 and minus 8, which is going to get me negative 264. Add 264 to both sides. Take the square root. 264 is divisible by 4. So I end up with the absolute value of x minus 16 equals 2, square root of 66. This is 6 and 11. Those are relatively prime and, sorry, not relatively prime, excuse me, don't have a perfect square hiding in them. And remember that because I took the square root of a piece that has a variable in it, and I can't take the square roots of negatives, I have to use these absolute values, which means x minus 16 can equal 2 root 66, or x minus 16 can equal negative 2 root 66. I add 16 to both sides. And in our case, normally we would have to actually go back and check that these answers really do work, in part because I'm worried a little bit about having negative answers, negative values in my x's. So really I want to see if this is negative. So 16 minus 2 times the square root of 66 is a negative number, and so that one is not allowed, so my only answer is 16 plus 2 root 66. 2 more examples. The next example, they may give you in several different ways. One possible way this example will look is they'll simply give it to you as simplify log base 2 of 32. They could also write this as log base 2 of 32 equals x and ask you to solve. So we actually kind of read this problem to mean this. And so I rewrite it as a power, as an exponent. And I can recognize that 32 is 2 to the 5th, and so x equals 5. Last example, simplify log base 7 of 1 over 49. Again, I'm almost treating this as if it says equals x, so I have 7 to the x equals 1 over 49. 1 over 49 can be written as 7 to the negative 2, so x equals negative 2.